So we are going to go into trigonometry. So when we're talking about trigonometry, it's not going to actually be like you're taking a trig class. Okay, we're just looking at ratios of right triangles. Okay, so ratios of sides of right triangles. So starting off here, the steepness of a hiking trail is often expressed as a percent of grade. The steepest part of Bright Angel Trail in the Grand Canyon National Park has about a 15.7% grade. This means that the trail rises or falls 15.7 feet over a horizontal distance of 100 feet. You can use trigonometric ratios to determine that this steepness is equivalent to an angle of about 9 degrees. Okay, so you can figure out how many degrees up that you're going up that hill using these trig ratios. So trigonometry comes from two Greek terms. Okay, the first one is trigon, meaning triangle. Okay, and metron, meaning measure. So the study of trigonometry then involves triangle measurement. So our trigonometric ratios, or trig ratios, okay, I'll just call them trig ratios for short, is a ratio or fraction, okay, so it's written as a fraction, of the lengths of two sides of a right triangle. Now this does specifically have to be a right triangle. Okay, it has to be a right triangle. So again, in bold here, for right triangles only, the three most common trig ratios are sine, cosine, and tangent. Okay, so we abbreviate sine as S-I-N, or you'll see it abbreviated as S-I-N, cosine as C-O-S, and tangent as T-A-N. Okay, those are what they are abbreviated as on your calculator. Okay, so you should know what each of those are. Okay, so sine is S-I-N, cosine, C-O-S, tangent, T-A-N. So the ratio for each of these. Let's focus, please. Ratio for each of these. So sine of A. A is the angle. So this capital letter here is talking about an angle. Okay, you always have an angle attached to each of these trig functions. So sine is opposite side over the hypotenuse. So over here, if I look at my triangle, this capital A is having to do with this angle right here. So we're talking about this angle. Now we want to find an opposite side over the hypotenuse. So we're going to write the trig ratio for this one. The opposite side means it's across from. Okay? Across from that angle. So if I'm finding sine of A, that would be lowercase a. Okay, so that's the opposite side. That will be over our hypotenuse, which is across from our right angle. Okay, the letter across from that right angle is lowercase c. So the ratio for sine of angle A would be A over C. Now we also want to find the sine of B. So this time you're starting at angle B. That's this angle here. I need the opposite side from that angle. So the side across from angle B would be lowercase b. And that's over the hypotenuse, which again is C. Okay, so just writing out that ratio or fraction. We're going to do the same thing with cosine. Okay, cosine now is adjacent side over the hypotenuse. Adjacent meaning next to. Okay, so adjacent means next to. So if I'm finding cosine of angle A, again starting at angle A then, I need the side next to angle A. Well, I have these two sides next to angle A, right? But what is C specifically called? The hypotenuse. So that's not your adjacent side. Your adjacent side then would be side B. Okay, so writing out cosine of A, I would have B, again, then over the hypotenuse, which is C. Okay, we're going to do the same thing for cosine of B. So starting at angle B, we need the side next to angle B. That would be A. Okay, not C. C is the hypotenuse. So that would be side A. Then that's over our hypotenuse side, which again is C. Okay, then moving to tangent. So tangent is the opposite side or across from and over the adjacent side, which is the side next to it. So for tangent of A, again starting at angle A, we need the side opposite that angle. Okay, the side across from that would be lowercase a. Over our adjacent side to angle A is what? B. Okay, not C. C is the hypotenuse. Okay, we're going to do the same thing for tangent of B. So going from angle B, we need the opposite side, which is lowercase b, over the adjacent side, that would be A. Okay, so just setting up those ratios of sides. Do you have questions on those before I move on? All right. Shh. Quiet, please. So trig ratios are found from the acute angles of a right triangle. You have to go from the acute angles. You cannot go from angle C. Notice how we didn't have any examples of tangent of C, cosine of C, or sine of C. Okay, you cannot go from that 90-degree angle. You have to go from the acute angles of your right triangle. Okay, if I went from C right here, my opposite and hypotenuse would both be C. Okay, that doesn't work. So you have to have those acute angles. So you cannot find trig ratios of the right angle. So that's what I was just talking about. You cannot find trig ratios of the right angle. So we're going to do some more examples finding these ratios. So we want to find the fraction for each, or the ratio for each of these. Then what type of angles would P and Q be? They would be acute angles. Okay, because we have to go from those acute angles to find those ratios. So we'll do a couple more together here. So first one, we have sine of P. So I need to start at angle P, and sine from our chart above is the opposite side over the hypotenuse. So the side opposite angle P across from, that length is 15. Okay, that's over our hypotenuse length. Okay, our hypotenuse length is 17. So that would be our fraction or ratio for the sine of angle P. Number 2, we have the cosine of angle P. So again, starting at angle P, cosine is adjacent over hypotenuse. So we need the side next to that angle. That's 8. That's over the hypotenuse, which again is 17. Last one, number 3, is tangent of angle P. So starting at angle P, tangent is opposite over adjacent. So we need the side across from angle P. That's 15. Over our adjacent side to angle P, that's 8. Okay, now we do have a mnemonic to help remember this. Okay, it's called SOHCAHTOA. I don't know if you've heard that before. Okay, it's SOHCAHTOA. So S is for sine. Sine is opposite over hypotenuse. Okay, so cosine is ca. Okay, cosine is adjacent over hypotenuse. And then we have tangent for T here, and that's opposite over adjacent for TOA. Okay, so this is something to remember so you know what those ratios are as you go through everything. Okay, otherwise, again, on the top of your, well, middle of your note sheet here, I do have those labeled out for you as well. So I want you guys to do 4, 5, and 6. So this time you're going from angle Q. Okay, so start at angle Q, find the sine of Q, cosine of Q, and tangent of Q. If you finish 4, 5, and 6 and want to go to the top problems on the back and do those ones, you can do that too. It's just more practice of finding that ratio. Huh? Yeah, so cosine of P is the same as sine of Q after you flip from different angles.
Oh gosh.
Those of you who did 4, 5, and 6, I do have those ratios up on the board, so make sure those are correct, because I know some of you went to the back and started that. Okay, does anybody have any questions on these 3 problems right here?
No, it's pretty simple.
Yeah? We're doing okay so far?
I don't know about number 8, but what do you mean? Oh, yeah. Yeah.
All right, so then some people started on 7. So just going through 7 quickly here, it's the same process. So when I say find sine of K, you need to start at angle K. Okay, sine is opposite over hypotenuse. So you need the opposite side or across from, that's 12. Over the hypotenuse is 13. Okay, then cosine of K. So from K, we need the side adjacent to over the hypotenuse. So that is 5 over 13. And then tangent of K. Tangent is opposite over adjacent. So we need that opposite side again is 12. Over the adjacent side is 5. Okay, then moving on to angle J. Finding the sine of angle J, that's opposite over hypotenuse. So our opposite side this time is 5. Over our hypotenuse is 13. Cosine of J, we need adjacent over hypotenuse. So side next to is 12. over the hypotenuse is 13. And then tangent of J, so opposite over adjacent. So 5 to 12. Those of you who started on the back, how'd you do?
Good.
Good?
I'm all right.
How we feel about our ratios and setting them up? Good? Okay. So, then looking at number 8. Looking at number 8. We want to find the tangent of 30 degrees to the nearest hundredth. I'm just going to keep it as a square root. But so if I say find tangent of 30 degrees, that means I need you to start at the 30 degree angle. Now tangent from the front is opposite over adjacent. That's your TOA piece in SOHCAHTOA, right?
Isn't that a mountain or a volcano?
What?
I was thinking Indian tribe.
TOA or SOHCAHTOA? It's not SOHCAHTOA though, it's SOHCAHTOA.
Yeah.
So since I'm going from this 30 degree angle, I need the opposite side over the adjacent side. So the opposite side here is X. So I'm going to label that with an O so I know it's the opposite side. And then your adjacent side next to 30 degrees would be this X times the square root of 3. So I'll label that with an A. So now writing this problem out, I need to write out tangent of 30. Okay, your angle is always attached to those trig functions. Okay, that's where your angle goes. So this is tangent of 30. That's equal to your ratio. So that opposite side over the adjacent side. So my opposite side here is X over the adjacent side is X times the square root of 3. Now if I have X over X, what happens? They cancel out. So I have tangent of 30 is equal to 1 over the square root of 3. How do I simplify that? Multiply by square root of 3 over square root of 3. Good job. So I end up with the square root of 3 over 3. So the tangent of 30 degrees is the square root of 3 over 3. So I just wanted to do this one so you know how to set this up right here. Okay? So your angle is always attached to that sine, cosine, or tangent. Okay? Your angle degree is always attached. Okay? That is one number itself. Okay? You can't divide by just tangent and you can't divide by just 30. Okay? You can't separate them. They have to stay together.
Okay, maybe I'm just dumb, but how do we get the normal 3?
Because you multiply it by the square root of 3.
Okay, never mind.
Because it'd be over the square root of 9. Sorry, I did that in my head. All right.
Could we pass over? Yeah.
So we're going to do another example here. Okay, these are more of the examples that you're going to see. So, number 9, a certain part of a hiking trail slopes upward about 5 degrees. Okay, that 5 degrees is right here. After traveling a horizontal distance of 100 feet, okay, that's on the bottom, along this part of the trail, what would be the change in the hiker's vertical position? So that's this length right here. So that's X, meaning we have to try and solve for X. So I need to use the angle that I'm given, which I circled here. I have to decide which trig function to use. Do I use sine, cosine, or tangent? So from that angle, I'm going to label the sides. So I'm trying to find this side here. From that angle, what side would that be? It's across from. That would be the opposite side, right? Now, since I have that variable, x, I don't want another variable, y, so I don't want this side. I want this side right here. Is that the hypotenuse or the adjacent side? That's the adjacent side. So I have O and A. If I have O and A, which one of my trig functions? I would use tangent. Okay, so I'm going to use tangent. And remember, I need that angle attached. And it'd be tangent of 5, yes. Okay, I need that angle measure attached. Now that is equal to your ratio of sides. So your opposite over your adjacent. So opposite is x over the adjacent is 100. Okay? So now I want x by itself. Okay, I want x by itself. So when I have something like this in all of these ratios, I am always going to multiply by whatever's in the denominator of that fraction. Okay, and you need to do that to both sides of your equation.
Does this work only on the tangent one?
No. So you want to multiply by whatever's in your denominator so that it cancels it out. So here I would have 100 times the tangent of 5 is equal to x. Now this is where you need your calculator. Okay? You need your calculator. So, here my calculator. You see this little DEG in the corner? Make sure yours says DEG, not RAD. Okay, it shouldn't say rad. Okay, if it does, I need you to press this DRG button and go over to DEG and press enter, and it should change it. Okay, so you want to be in degrees because we're working in degrees right here with this 5. So on this type of calculator, to enter this, all you're going to do is press 100 times. Okay, 100 times. We need a tangent. Your tangent button is TAN right there. Press the tangent button. It should pop up. Plug in 5 and your parenthesis. Press equals. That's your answer.
You don't have a reciprocity.
No, you don't. Okay, so you should get x to be 8.7 feet. So that's with this calculator. Okay, if anybody has this one, you have to press second, and you have to press this trig or pi button, and then you have to select sine, cosine, or tangent. And then it'll pop up. Okay? Anybody else have a different type of calculator?
It actually feels like
Anybody else have a different calculator?
Yeah, you played.
No, but like, but I didn't actually play. One day, you actually played.
Pretty sure
I did play. It takes like the second night wasn't.
I wanted to
I know.
all got on his feet. I'm thinking about buying this one because I honestly just want to play and I don't want to have to save up $900. I texted that guy. He's
All right, so I want to keep going here so that we can do a couple more examples. Those of you who do have a different calculator, I'll help you change your settings in a little bit. But I want to continue. So, second part to number 9. We have to find the distance that the hiker traveled. That's this other variable right here, y. Okay, so that's what I want to find next. So that y length on your triangle, what would I label that as? The hypotenuse. Okay, so again, I have to decide which trig ratio to use. Okay, I don't want to use the one with x, so O is canceled out here. So I have A and I have H. Which one should I use? Cosine. Okay, I want to use cosine of 5 because that's the angle that I'm going from. Okay, that's equal to your adjacent side, which is 100, over your hypotenuse, which is y. Now remember I said we always have to multiply something on both sides. What did I say you have to multiply by? The denominator. Okay, just because it's a y doesn't mean you change anything. Okay, you multiply both sides by y. Okay, whatever's in the denominator, that's what you multiply by. Because we want to cancel those out. So now what I have is y times the cosine of 5 is equal to 100. Now I want y by itself. What should I do? Yes.
Like it. Good job, Ryan.
You want to divide by cosine of 5. Not just 5, not just cosine. Those are both attached to each other. Okay, so they cancel out here. So we have y is equal to 100 divided by cosine of 5. So again, I want to enter that into my calculator. Okay, so I have 100 divided by, press our cosine button right here, of 5, and press enter. Or 0.4, yep.
What? I got 99.
Sorry, okay? Yeah, I don't know why.
Did you end your parenthesis?
Yeah, I did it multiple times. So it's 99.61.
Oh, because you're not dividing, you're multiplying by 100. 100 divided by.
I saw that last second. There we go. Makes sense.
I saw that.
Got it.
All right. How we doing on that one? You still with me? Yeah? Okay. All right. We just have 2 problems left here. Ready? So, number 10. When I get a problem like this, first thing I do is locate the angle that I'm given. That's not the right angle. Okay? So not your right angle, but the acute angle. Okay? Next, I identify my sides from that angle. Yes, you are. So from this angle, I have a side across from it. That's O. Opposite. I also have this side next to it. Now I have to make sure I'm identifying it as either adjacent or hypotenuse. Which one is it? Adjacent. It is adjacent. Okay, so I have O and A. So that means I need to use tangent. Okay, so I have tangent. I have tangent of 25 because that's the angle I'm going from. Okay, that's equal to my ratio of sides. So the opposite side is x over the adjacent side is 18. Okay, what am I multiplying by?
18.
Okay, so I end up with 18 times the tangent of 25 is equal to x. And you can plug that into your calculator. Make sure you know how. Plug it in before I give you the answer.
Yeah, 8.
Wait, how do you know when you divide? How when you multiply?
Here, you'll have a fraction, you divide. Here, if you're multiplying through and you don't have to divide by anything to get x by itself, then you multiply. Okay? You should have gotten 8.4. Should have gotten 8.4. To 8.4, yeah. I don't know. I used to do that sometimes. I don't know. Yeah, no, on quizzes and tests, I'll tell you what to round to. All right, I want you guys to do 11 while I pass out your assignment. Okay, so do number 11. Go from your angle, figure out which trig ratio to use.
Okay, alright, yay. Homework. Yeah, so let's do 11. Why do we have so much?
It is not that bad, I promise.
Yeah, unless you have 10 or 17. I still have to pretty much
Right now. So you choose which side or if
You have to do both. I'll let you know what the front is though. All right, so those of you who did number 11, you should have used cosine. Okay, you have the adjacent side and the hypotenuse, so use cosine. Cosine of 70 is equal to 15 over x. You need to multiply both sides by x. Then you need to divide by cosine of 70, so you have 15 divided by cosine of 70. Now when you plug that into your calculator, you should have 43.9. 85. Because I'm going from this angle, the side opposite that angle has to be across from. So this side would be your opposite side. Other questions? Before I explain what you're doing on